Hello, once again welcome to my channel. Today we are going to discuss about photodiode. So what is a photodiode? It's a special type of PN junction that generate current when exposed to light is known as photodiode. Photodiode is a PN junction diode actually. But this is a special type of diode which generate current when exposed to light. So it is working with respect to the light energy. That type of diode is called photodiode. So it is also known as photodetector or photosensor. So photodiode operate in reverse condition, that is reverse bias condition. Photodiode is operate in reverse bias condition. That means if this is a diode, the diode is working a reverse bias when positive is connected to negative and negative is connected to positive. This is reverse bias condition. So here also photodiode is working a reverse bias condition. Here P side of the conductor, that is P side, that is positive of the conductor, is connected to the negative terminal of the battery, and the N side is connected to the positive terminal of the battery. And this is the symbolic representation of a photodiode. So here we see that the photodiode is nothing but a PN junction diode. From the symbol we can visualize that it's a symbol of a PN junction diode, but it operates with respect to the light energy or electromagnetic radiations, or so it is with respect to light, so it is called photodiode. So this diode can be work how all the properties that of ordinary diodes, can be act as a switch, etc. Okay. Then principle of photodiode is photoelectric effect. So the working principle is based on the photoelectric effect. That means photoelectric means when light energy is received, some electrical energy is generated. That is the basic principle of photoelectric effect. So the operating principle of photodiode is such that when the junction of this two-terminal semiconductor device is illuminated, then electric current start to flowing through it. So as the name indicated, when this device is two-terminal device is illuminated or some solar for light energy is received to this device, then electric current is start flowing through it. Otherwise, no electric current is flowing through, no current is flowing through it. So only minority carry flow through the device when the certain reverse bias potential is applied. As I said earlier, it is working in a reverse bias condition. Normally, in a reverse bias condition, there is very minute current is flowing, that is called dark current. So when this diode is illuminated by the light, illuminated or apply some light energy, then it start to conduct the electric current. So this is the basic principle behind the photodiode. The structure of a photodiode is shown here. Say PN junction diode, which is formed by P-type semiconductor materials such as boron and N-type semiconductor materials such as phosphorus. Here we show the construction of the photodiode. Here this is a N-type substrate, say heavily doped N-type substrate. Through it, a P-type substrate is doping, that is lightly doped P-type material is doped into this N-type material by using diffusion process. Actually, PN junction is made in such a way that we'll be take a substrate. It is either it is a p-type or n-type. Here we'll be take a n-type substrate, and this n-type substrate is heavily doped. That is n plus is there, and through this n-type substrate, we diffuse a p-type material like this. We will be create a small window here, and we will be diffuse a p-type material. This is silicon dioxide layer. This is here. This is silicon dioxide layer, SiO2 layer, and this is a window. Through this window, we diffuse a p-type material into this n plus material. And due to this p-type and n-type, there is a diffusion region will be created, formed like this. Or p-n junction is formed by this method. By theory, we will be take a p-type material, and then we will be take a n-type material, p and n and p. Then there is a we join these two junctions, they form a depletion layer. Actually, we cannot form a p-type material, p-n junction like this. So p-n junction is formed by diffusion process by like this. So here it will be seen like that, and there is an n-type substrate is there. To this n-type substrate, a p-type impurity is diffused to here, like this. P-type impurity is diffused, then a pure region is formed here. This is a pure region. And then a depletion layer is formed like this, ordinary p-n junction theory. And there are two regions are there. This window region is called active area, and this silicon dioxide region is called non-active area. So we will see the next slide. So as I said earlier, a p-n junction is formed by diffusion of lightly doped p-type impurity into the heavily doped impurity. Here, the heavily doped impurity is the n-type material substrate. To this n-type substrate, we will be doped at lightly doped p-type material like this. Okay. So the contact parts are developed at n-type area called cathode. This is called the cathode, and there is a contact area in the p-type material. It is called anode. This is silicon dioxide layer. It's a non-conductive layer. So in this figure, we see in this figure some portion of the front area called active area. That means this area is the active area, which is coated with anti-reflection material to reduce the reflection of light, and rest of the area is called non-active area, is coated with a thick layer of silicon dioxide layer. So this is the active area. This silicon dioxide layer in two sides are called non-active area, and this is a contact with the p-type material. It is called the anode, and there is a contact with the n-type material. It is called the cathode. So this is the construction of a photodiode. So the responsiveness and speed of this photodiode to convert light into current can be controlled by controlling the thickness of this non-active area. These are two non-active areas are there. Active areas are there. By controlling the thickness, we can improve the speed of this photodiode operation. So photodiode, once again, photodiode operate in reverse bias mode only. Means negative voltage is applied to anode, positive voltage is applied to cathode. Reverse bias means negative is applied to anode. Here the anode is p-type material, and positive is applied to the cathode. Cathode is here n-type material. The operation mode of photodiode. There are two modes of operations are there. First one is called the photovoltaic mode. In this mode, there is no biasing is given. So it is called the zero bias mode. Actually, diodes can be biased in two ways. That means, as the diode have two terminals are there, actually diode have so you see the diode have two terminals. This is positive terminal and this is negative terminal, or P type or N type. As it has two terminal and we have one battery is also two terminal, positive and negative. Battery has also two terminal, positive and negative. So there are two combinations are possible. That means the positive of this battery is connected to the diode is connected to positive of the battery and negative is connected to negative of the battery. And this is called forward bias. When reverse connection, that is positive is connected to negative and negative is connected to positive, negative is connected to positive and positive is connected to negative, it is called reverse bias, forward bias and reverse bias. So that is photoconductive mode is known as zero biasing mode. That means there is no biasing voltage is applied to diode, because no external reverse potential is provided to the device. That is why it is called the zero bias mode. However, the flow of minority carrier will be take place when light energy is received by the junction, exposed to light, and this mode is called photovoltaic mode. So photovoltaic mode means zero biasing mode. Then photoconductive mode is when certain reverse potential is applied to the device, then it behaves as a photoconductive device. So applying biasing voltage to this device, then it is called photoconductive mode. Here an increase in the depletion width is seen with the corresponding change in the reverse voltage. So applying more reverse voltage, more depletion there will be created, and so that there is less flow of current to the PN junction. So these are the two operational modes of photodiode. Then let us see the working principle of a photodiode. So in the photodiode, a very small reverse current flow through the device, that is termed as dark current. When this device is connected to in a reverse bias mode, there is a small reverse current is flowing through this junction due to the minority carriers present in the N type and P type. And due to this minority carrier, here the minority carriers are these positive charge particles, and here the minority carriers are the negative charge electrons. And this negative terminal is connected to the this N-type material is connected to the negative terminal. There is a repulsive force of these negative charge particles and a negative terminal of the battery, so that these negative charge particles are penetrate through the depletion layer, as well as positive charge particles repel due to the positive terminal of the battery, and this is also penetrate to the junction. And due to this current flow, there is a minute current flow through the junction, and that current is called dark current. It is called because this current is totally the result of the flow of the minority carriers, and thus flows when the device is not exposed to the radiation. So when a device is not exposed to radiation, then current flow due to the reverse bias voltage is called dark current. So again, the electron present in the P side and holes present in the N side are minority carrier. Here these are electrons present in the P side, and these are holes present in the N side, and these are called minority carrier. When certain reverse bias voltage is applied, then minority carrier holes from the N side experience a repulsive force from the positive potential, of the battery. Similarly, electrons in the N side, so electrons in the P side experience a repulsive force due to the negative turn potential of the battery. And due to this movement of electron and hole, recombination at the junction result generating depletion region at the junction. This depletion region is formed due to the movement of these electrons and the holes recombination process. Due to this movement, a very small reverse current flow through the junction device is known as dark current. As I said earlier, the combination of electron and hole at the junction generates neutral atom at the depletion, due to which any further flow of current is restricted. So this is the reverse bias condition of the photodiode. When light is applied, now let us junction is illuminated by device is illuminated with the light. Here the light energy is illuminated to the junction. So as the light falls on the surface of the junction, the temperature of the junction increases, and this causes electron holes to get separated from each other. There is covalent bonds are formed here. These bonds will be receive energy from the light source, and it will be get separated. Electrons and holes will be get separated. Then at the two, that is electron and holes that separated, then electron from the n side get attracted towards the positive potential of the battery. Here are the electrons. These electrons are attracted to the positive terminal of the battery. So electrons will be moved to this. These red color portions are electrons. These are electrons. Electrons is moved to the positive terminal of the battery. And similarly, holes present in the p side move to the negative terminal of the battery. So this movement generates a high reverse current in the device. And due to this movement of charged particles, there is a current is generated, that is the reverse current of the device. So with the rise in the light intensity, more charge carriers are generated and flow through the device, thereby producing large electric current through the device. And this current is then used to drive the circuit of the system. So this is the working of the photodiode. When light is receiving, then electron hole pairs are generated, and these electron hole pairs are flowing through the junction, and that is thus current is flowing through the device, and this current is used to drive the circuits of the system. So we can be say the intensity of light energy is directly proportional to the current through the device. Only positive bias potential can put the device in no current condition in the case of photodiode, or by applying positive biased potential we can off the device. So this is the working principle of the photodiode. So by using this photodiode device, we can sense the light intensity, and we can on or off some switches or controlling instruments corresponding to the light. So this is the main application of this photodiode. So now let us see the we have already seen how the working principle and construction of the photodiode. Then let us see the characteristics curve of the photodiode. So the figure shows the VI characteristics. As it is in a reverse bias condition, it is a negative part is shown in the graph, that is negative voltage is there, and with respect to voltage and the current. So voltage is here, the vertical line represents the reverse current flow. This is the reverse current flow through the device, and the horizontal line represents the reverse bias potential, that is minus V voltage. So here the first curve represents, this curve represents the dark current that, this curve represents dark current that generated due to the minority carrier in the absence of the light. As we see earlier, when this diode is illuminated to the light, then it will be conduct electricity. So the first curve in the figure shows represent the dark current that generated due to the minority carrier, the absence of light. The absence of light, this is the characteristic curve that is called dark current, and this very minute current is there. As we see in the figure, that all the curves show almost equal spacing. All the curves show almost equal spacing between them. And this is because current is proportionally increased with the luminance lux. That means current will be proportionally increased with the luminance lux, so this spacing is almost constant in all the curves. By increasing the luminance, more current will be flowing through the device. So the next slide shows the curve of current versus luminance. By increasing the luminance, we can see that the current is also increasing. So this is the characteristics of photodiode. Characteristics curve for the photodiode. Then advantage of photodiodes. First, it is a quick response time, response to light. Then it offers high operational speed. It provides linear response. It is low cost device. So these are some advantages of photodiode. Disadvantage is it is a temperature dependent device and shows poor temperature stability. And when low luminance is provided, the amplification is necessary. That means when a low luminance, there is a small current is flowing through the device. And in order to measure that luminance, we require some amplification process. So these are the advantages of photodiode and the disadvantages. An application of photodiode. Photodiodes are used for photo detection. That is to detect the light energy, that both visible and invisible light. Used for character recognition, like barcode reading, like that we can be used photodiodes. So photodiodes are majorly find the use in counters and switching circuit. It is used in optical communication system. Again, logic circuits and encoders are make use of this photodiode. And in the case of typical photodiode, normal reverse current is in tens of micro range. So these are the 5 applications of the photodiode. In normal conditions, the reverse current is in tens of microampere range. In tens of microampere range, normal case, the reverse bias current is there. So these are the advantage, application, construction, working principle of photodiode. Now I think you can follow me, and thank you for listening me.